Welcome to India series. In this session, we'll talk about how to use Git as your Terraform module registry and also how to handle the versioning and the best practices around that. To give a brief introduction about myself, Vasan, having close to 8 years of experience in IT, and I play a senior cloud engineer in a private company called Mindera. You can connect me in LinkedIn under @Keerthivasan-Kannan. Myself also hold 5 AWS certificates plus Terraform Associate certified. As a hobby, I run 2 YouTube channels, one eVidai and the another one TechPage. Both I make content around AWS, DevOps and Terraform. The eVidai I make content in English, whereas the TechPage I make content in the regional language Tamil. The today's agenda is going to be, we start with what is Terraform, why Terraform, and why not any other providers other than Terraform. Also, we talk about how to create a sample resource using Terraform and the purpose of the module itself, why not limited to resources, why we need module, and how to place a module in a centralized location, something like Git repository, and how to handle the versioning for the modules placed, and what are the best practices to tackle when placing the modules in the central location like Git. So that's the entire agenda it's going to be. So I would be around in the YouTube chat session all over during the session. So for any queries, feel free to ask in the chat, or you can also reach out over LinkedIn if you're watching the recorded version of the session. As many of you know, the Terraform, it's mainly used for as an infra as code approach, so that we don't go and manually create the resource and we do it as a code format so that we can track what actually is getting changed and the history of the infra itself. Also, it's easy for the state file management. We can see like what resource has been created and how it is being currently managed. It also helps you to track your change, like who changed, what been changed, and so on. The same thing can be also offered in other competitor services, but why Terraform, or what cutting edge Terraform providers? It provides multi-cloud. So if you are in AWS, you might be limited with a specific infra code provider that is limited to AWS, whereas Terraform, it also supports Azure, it also supports AWS, GCP, and so on. It's not just limiting to multi-cloud, but other than cloud services, the Terraform providers are also available in multiple areas. For example, if you're targeting about DNS, then there is a provider for Cloudflare, and this is a sample list which you can self-explore by visiting the page Terraform browse/providers, where you can see all the list of providers which is currently associated with Terraform to see like what you can make infra code in your day-to-day life. So it's easy to say, like you can avoid manual change, you can avoid track the resources. So to see it in action, like how much difference it can make with and without the code. So for this scenario, I took an example of creating an S3 bucket manually and also destroying the S3 bucket manually. Let's see like how many click and how many ways you want to navigate it. So if you see, like first I make one click for creating a bucket, and then the second click for typing out the bucket name, and here the chances of making typo is there, and then you scrolling down and then making the third click for creating the bucket. So just for creating a bucket, I'm making 3 clicks. Now the same for deleting the bucket, I already made one, and now I want to make the second click and type all the way of the naming conventions of what bucket I need to create, and then the third click for deleting it. So it took 3 clicks for creating a bucket, typing out the name, and another 3 clicks for deleting. Again, I need to type the bucket name which I want to delete, and in both the process there can be a manual typo can occur, and there is no peer review exist in the entire process. So let's see how it would look in the world of with Terraform. So we will be replacing all those actions with just 4 lines of code with a resource block. That's how it's going to ideally look, and we are going to input this the bucket name alone as part of it, and when we execute it, it's going to be just the 3 commands. So first you are going to initialize the code locally, and then you would do the, once the provider has been initialized locally, then you are going to perform the apply action, and it would ask you for the confirmation that these are the resources are going to get created, changed, or destroyed. And if you're happy with it, you can provide yes. Even you can provide the yes step by using hyphen auto approve flag by passing it, so that it won't even ask you for approval. It's more like a pre-approved state, and done. Your resource will be created. And now, from now, once you have the working code, you can destroy the resource with just a single command of terraform destroy. And if you want to recreate it, you can recreate it. If you want to destroy again, you can destroy and play with it a number of times. So I took S3 as an example over here, whereas the same case would apply for EC2 or S3 or Lambda. And think about a complex scenario where you want to build your infrastructure which would need multiple components like load balancer, backend server, the front-end certificate, and so on. So with this infra code approach, you can avoid all those hassle of clicks and huge chance of error, and everything can be converted into a bulletproof mechanism of infra code. So there's a major difference between with and without the Terraform. So now if you see the code itself, it's not just the resource creation, right? I might be having some additional scenarios like updating of tags, which is again I can easily pause it. Or I might be having some standard set for my company. For example, let's say whatever the S3 bucket I create, it should have a prefix TP hyphen in front of it to identify it's a company bucket. Or you want to mandate the tag for your cloud pricing visibility, so that you might need to mandate what tags to be created as part of the resource creation, right? But then if you see in real world, the most person who need of the AWS resource might be your developers, and you don't want your developers to worry about, am I passing the right tag or am I passing the right naming convention which my company wants to, because they might be having a lot going on. So also even if you're passing the responsibility to the developers or the person who are creating the resource in your org, then again you would end up in terms of repeating yourself, as if for each S3 bucket you create, you end up passing the tags, or you end up typing a TP hyphen as part of the resource creation. The best practice when it comes to coding, it's something called don't repeat yourself, the dry concept. And that's where exactly the module kicks in. So the module helps you to variabilize the repeated standard of your code. So in this case, it would be the TP, which is a prefix, should be like standardized, and also the tag which you want to hard code it. So that's how the module can be formed. And you might be noticed like it's still a resource block, right? So what's the difference between a module and resource? So in module, you create a resource with variabilized format, and then you would be referring that specific the resource block within your module block and get the resource created. So if you see on the right side in the module section, that's how the folder structure would look like. Within the S3, the resource block would lies, and then within the demo folder, your actual module block would lie. So the quick demo for like how it would look like when we are trying to create a resource. So you're going to keep the module block within the S3, and then in the demo block, we're going to actually create a resource, and both the folder would contain the definition of providers, because it would need to know what are the prerequisite providers it would need to use. And all you would need to do is you would say the initialize the one Terraform init, and then you would do the Terraform apply post creation. So let's say for a developer, they might be having a requirement for creation of another bucket, right? So all they can do is they can just use the same module template, and then just pass the new bucket name that they would need in, so that you are not repeating yourself, or you are not worried about is a new resources created with the right tagging, or is the naming convention is followed by the developer. So in case if you want to avoid like duplications of like for example in this case we are saying like prefix it with tp-tp, right? So if you want to avoid the duplication of like tp-tp, then you can play with validation and other things in the variable. I'm not going deep into that, but this is how you can simplify the process of the creation of the resource and templating it with the module. So far what you have done is we are creating the module and keeping it all over the place of locally. So everything is happening within the folder structure, and even we are referring the folder with dot dot slash s3, which is like locally exists, right? So how we can use Git as a module registry. So all you would do is whatever the files which exist under the S3 folder, because that's what we are using as a module when we are doing it locally, we'll be placing it in a Git repository. So in this case, I created a repository called Hashi module demo, and I'm just following the same folder structure like S3 and move all those files from a local system into the Git repository. The push commands for Git repository might be out of session, but you can also go to the UI of the Git if you're not familiar about Git, and it's basically a versioning control system where you can track what changes been done, who made it, when, all under the commit history. So now, so far we are referring it locally, right? The source block, it says the folder of the S3. So since we are moving it into a Git repository, all you would need to do is just change the source block value into the Git repository. So you would need to pass the value of SSH equivalent of the URL for your Git repository, and that's it, it will start working. But here, if you see, we are directly mapping it to the Git repository, but our folder structure, which in our example, the actual module is not lying in the home directory, but it is lying within a folder called S3. So how we can say or Terraform saying that, hey, this is a module, you don't directly refer to the home directory of the repository, but I want you to precisely go and look into a folder called S3. So how can we say that? It's very pretty straightforward. All you need to do is from the value of your repository SSH value, you need to suffix it with / your folder name. Since in our case, I named the folder name as S3, I'm adding the suffix of S3. If you're creating a module for ALB in the folder name ALB, then you can say like / ALB. So it's just the folder name. If you're having like folder subfolder, then you can say like / S3 / let's say bucket, something like that. But in our case, it's straightforward. So which lies within the first folder called S3. So I'm naming it as the S3 itself. Okay, so now comes the part of versioning. Why versioning? It's not just part of the code, but our module also will evolve as our organization evolves, right? Because currently I might be having a requirement like my S3 bucket should prefix with the value TP, and it should contain the tags name and environment in it. What if tomorrow my organization will change? I want to rename from TP into uh, EVDI, or what if I want to add additional tags as part of my resource for some building purpose, maybe like team equal to. So it can change, for which the versioning of the module is mandatory. So how can we handle the versioning when we are moving into Git? Is by using the tagging options already available as a Git itself. So you would just need to know the two commands to tag your changes. The first command to tag your change would be git tag -a, and then the version. So in our case, I'm just making this 1.0, and you can give the nodes for your version, like what changes you are doing over there. This can also act as a change log, and then you can do push your changes or push your tags to the remote repository using a git push --- tags. And now if you go to the Git repository, you would see the tag section over there, and if you click there, you can see the version number of your tag, and then the nodes which you added when you created the when you push the changes over there. So now we have created a tag, but how can I tell my Terraform you need to refer this specific tag or this specific version, right? So currently, if you recall, we are just saying go to this repository and this folder, but now we want to say Terraform go to the specific tag of the repository. So to do that, you would use a ref query parameter like question mark ref equal to your tag name, so that the Terraform knows it's not just to fetch any the main branch, but it would need to precisely specify the requirement tag to fetch it down under a specific folder called S3 and then execute the command from there. So this is how you can handle the versioning in the Git. So the major common versioning strategy they use something called semantic versioning. It goes something like this. You can see like 1.0.0 and any new changes you put it into the module, you can bump the numbers based on the impact it creates to your module. So the standard they follow is the first one or the first value here they stand it's for major one, which means it's going to break your existing change. So let's say I'm renaming my TP into E with I or XY, then the existing S3 bucket would get destroyed because I can't just rename the one, right? So which means it's going to break my existing infrastructure. It's going to create an impact. So in that case, it's a major one. So if I'm going to rename my resource or it's my resource is going to destroy, in those scenarios, I would bump the version 1 to 2. The minor is something, you're adding something new to the existing setup, but it's not going to create a major difference. Let's say I'm going to add a new tag value like team name equal to the value of the team name. So in this case, it's just appending a tag to the existing resource. It's not going to create a huge impact for the existing resource. So in that case, I can just bump the minor version of it. The bug, it can be like, let's say you started with environment as E caps, but you realize you want to have everything lowercase, so you are updating the module from the environment tag name from E uppercase into the E lowercase. Then it's more like a bug or a minor fix. Then that you would add the final 0 incremented one. So hope you got the difference, like a major, minor, and bug. So major is more like there is no rollback. Minor is like if you want to roll back, you can do that, and it's not going to destroy any of your resource. And bug is more like for the existing change, there can be a typo or some adding nodes or likewise. So taking this approach of semantic version can create chavos like what exactly got changed, right? It can be a tricky part. So that's where you would need to maintain something called change log as a best practice, so that you know what changed and what exactly the difference between 1.0 and let's say if you're introducing new version 2.0, what change it got introduced as part of 2. So when you go as a Git repository module, you same like how you should do for like readme.md, you can also do the same thing for changelog.md, so that you have a proper version like what changes and what are the new changes from the difference between version A and version B, and people can choose either they want to update their version or not required. So now let's talk about few best practices which you need to keep in mind when it comes to taking this approach of moving the repository into the Git one itself. Yeah, so moving the module into the Git one. The main one for the first thing is keeping the end user, build the module, keeping the end user in mind. So what we meant by this is we don't want to complicate end users, or like we don't want to collect details like for example tags, right? So all those tags can be done behind the scenes, and you get the bare minimum requirement from the end user, so that they provide very minimal input, and the infra is created backend with all the standards you need. And don't try to make it region bounded, like don't add providers of US specific within the module, and give that part into the resource creation people, so that when they are referring your module, they can choose where your resources to be created. Else that's create chavos in future if they want to expand the resource creation to different region, then you want to bring in additional changes to your module which is unneeded. Variabilize as much you can, so which means don't hard code it, hard code the things which you want to standardize, whereas even if there are something like you wanted to standardize, let's say like TP, and you want to change it, you can variabilize that and then keep the default value as TP, so that when they are creating a bucket, if they pass it, they can create with a custom prefix. You never know when the requirement change, and if we can variabilize as much we could, even there is a minor exceptional case which you want to divert it, we don't need to do any changes in the module, and still it can be done with the variable itself. Also document the details with sample. Let's say if you're creating a module in a Git repository, it's wise to create a folder for sample folder, so that if any of the user is referring your module, they can see how the module block to be called and what are the mandatory variables to be passed to get the resource created using your module, and are they, so that if they're complete new beginner to the Terraform, they don't need to go here and there to get the resource created. They can just use your snippet and documentation part, get the resource done. If you're planning to create resources or create module for multiple services, let's say S3, EC2, Lambda, and so on, or maybe like cloud provider, or maybe the cloud front, or many. In those cases, try to create individual repository so that you have each repository act as a module, and if any update required for the module can be handled without impacting any other, else the versioning and other things can make a bit tricky if it's all went into a single repository. You can also create a module combining other modules. For example, for a website, you can have S3 as a separate module, and load balancer or EC2 as a separate modules, and then make a combined module together as a separate repository. So there are like multiple ways to handle it, but always try to go as an individual repository per module based cases. Yeah, so these are the generic best practice how you can handle if you are like a low level company, or like you are using Terraform but not to a certain huge impact, and you don't want to spend so much money on third party providers like Spacelift or for your module management. Those things can be handled in a simplistic way using the Git as a module registry. So that's more around this session, and that's what I wanted to share it today. So if you have any questions, feel free to ask. I will be around in the comment section of the video, and you can also reach out to me over the LinkedIn. Yeah, so thanks all for your time. I will be waiting for your queries to get it answered, and this is my LinkedIn handle where you can ping me or we can connect and discuss further of any of your future questions, or if you're trying it on your own, you're facing any hands-on difficulty, feel free to reach out to me. So thanks for the opportunity and thanks for your time. Cheers.